In an earlier post, I was telling you about JavaScript's async and await and also promises. And I've kept meaning to get around to doing the same thing or the equivalent thing in C#, where rather than a promise, we have a thing called a task. Now in C# and .NET, a task is rather more than a JavaScript promise. It gives us everything we might possibly want to do with threads, creating threads, synchronizing threads, that sort of thing. But all of that would take not one, but several other videos to go through. So I'm just going to focus on that one thing related to tasks, which is how they can be used with the async and await keywords. So what I've got here is a fairly simple console application, and the class I'm going to be using is the web client class. Now, web client's actually getting pretty out of date now. Nowadays, you'd probably use HTTP client, but the reason I'm using web client is it shows you kind of the history of all of this and the various ways we can do it, leading up to the most modern way of using async and await. And what web client allows us to do is simply make a call to any website and get the results back. So here in this blocking function, I'm doing that in the old-fashioned, and most people would say wrong way. By blocking, I'm simply printing out a message saying we're starting the call, then I'm making a call with open read to the BBC website, just as an example website, and that is not going to allow the program to do anything else until those results come back. And those results come back as a stream, and then we're just reading the very first line of that. So just to confirm we've got the data back, obviously we can process it however we liked. And I've put messages saying when we're starting the call and when the results come in, and we can see in main, I've got that waiting there. And if we run that up, we can see it says starting call, results in, and then prints the results. But because that's blocking, if I just put a break on there and run up to that point, when we step over that call, it takes maybe a second, certainly a certain amount of time that in most applications we wouldn't want to be sitting there doing nothing, because if things were going wrong, it could take longer than that. We would like to have a chance to do something else. So blocking is generally not what we want to do. So the next step forward from that is to use a callback, to use an event basically to notify us when the work has been done. So that's what we've got here. So I'm still using the same web client, but in this case, I subscribe with an event handler to the open read completed event. And in there, we get these event args, and the event args has a result property, which is the variable that's coming back. So we can see up here, that was the stream we got back. Now, when we do this open read async, we don't get anything back. But then when the operation is completed, we'll come in here, we're saying results in once again, and then we've got the result to display. So if I just comment that out and then put in our call to with callback, and you can see the other thing I've done here, as well as calling with callback, I've sent us to sleep for 2 seconds. You need to do this because otherwise the console application would terminate before the results were in and we wouldn't see them. So in a normal program, you wouldn't need to do that because you'd be doing something else anyway. But because we haven't really got anything else to do, then just going to sleep for 2 seconds is the best way to go about this. So we can see the process then, and if I run that one up, then the important thing is we're starting the call, and then I've printed out this message doing something in the meantime, and then we get the results back and the first line of the HTML. And so you can see after I made the call here asynchronously, then I could pop out a message or do anything that I liked. And so then we'd come back into the sleep for 2 seconds. And then when the result came in, we would jump to that event handler and display the results. So again, let's pop a break in there and also a break on there and run that up. And we can see that when we step over, there's no waiting there at all, really. We come back out of the function, but then when we go into the sleep, we jump to the result, which has come in the meantime, and that prints out the result. And so that's doing it asynchronously. We're not blocking. We can do other things if we want to. But in terms of programming, the layout is a bit messy because we have to write a completely different function to process the results from the one that we used to actually set off the request. When we do it synchronously, it's nice in terms of the program layout because once we've got our stream, we can immediately use it. Whereas with the asynchronous one, we've put that in a separate function. And that would mean if there are additional data items we wanted to pass in there, say we had a local variable in here, so we had a string message equals my message, then that variable message is not available inside the callback function. Various ways we could get around that. We could make it a member of the class, but that's a bit of overkill for what we might want to do there. We can actually pass it as an additional parameter here, so I could pass message in there, and then here we can do a console write of e dot and then user state. And so now if I run that one, we can see that the message is being passed through just there. Or in fact, we could have turned this into a local function, actually putting it inside with callback, and then message would have been available to both of them. So there are ways around it, but it's certainly not as neat as just being able to write a function that blocks and then deals with the results. So that's where our task comes along. So what we've got now is this with async version. And the really nice thing about it is structurally, it is almost exactly the same as our blocking version. So I'm actually going to take all of that blocking code and put it into the with async. But then rather than doing open read or open read async, I'm going to do open read task async. And this is what I'm saying is the nice thing about the web client. It does show you all three mechanisms for doing it, whereas the more modern classes only give you the modern way of doing it. And so we can see there, we've got this open read task async. So what we can see as a result there is a task instantiated for stream. So stream was what we originally got back up here, but now the task async version returns a task for that. But all we need to do is put the word await in there, very similar to what we did in JavaScript. And now that means that the type of stream is no longer a task for stream, it is the actual stream. And the one we've got to follow here, exactly the same again as JavaScript, is if you've got a function that contains an await method, it has to have an async declaration. We saw earlier, actually, when I didn't have anything in there, we are allowed that async declaration, but it gives us a warning saying that we've got an async method without an await in it, and there's not really much point. But it's not strictly illegal, but once we put at least one await in there, then everything's happy. And so what we can see we've done here in calling that, I've called with async and then popped out a message just showing we can do something in the meantime while we're waiting for the result. Then again, we go to sleep. And so we should, if this is working asynchronously, see the doing something in the meantime and then the results in and that result. So if we run that up, we can see it's starting the call, doing something in the meantime, then gets the results. So the behavior is exactly the same as the version with the callback, but the structure of the program is much, much nicer because it's laid out in exactly the same way as the blocking call. And so if I go through that in the debugger, we can see a much more natural flow. So we'll hit that point, step over there, step over there. You see, while we were waiting in the debugger, it went back out to the main function and did something in the meantime, and then we can step through the rest of it and get the results. So that's essentially it for this kind of use of async, await, and tasks. We're not using tasks to create threads, though that is being done internally by this web client, but we are managing the flow of that, and so using async, we get the best of both worlds. We get the structure, nice and simple, one function, just as we did with the blocking code, but we actually get the asynchronicity that we can do something else while we're waiting. Now, this is slightly more complicated than what's happening in JavaScript because in JavaScript, we actually don't really have any genuine multi-threading, but we do have that available in C#. And so just to show what's happening with threads, I've just got this report thread, which prints out the current thread IDs. So if we put a call to report thread just before that blocking call and just after that blocking call, and then reintroduce that bit of code, then we'll see, as we'd expect, that it's all happening in the same thread. So the thread ID is 1 in both cases. Whereas if we switch to the with callback version, and we'll put the first call to report the thread just before that call, and then in the callback is where we'll put the second report thread, and then in that case you'll see they're in different threads. The numbers don't really matter, but 1 and 4 clearly different threads. And that's exactly the same if we use the with async version. So if I put a report thread before and after in there and run that, then we can see again they're in different threads, even though they're in the same function. So we can see that when we call the await, we then leave the function, and then when the results have come in, we're back into the function, but we're back into the function on a different thread, and that's showing exactly how it's working. Now that's not the case in JavaScript, and it's not always the case in C#. It's the case here in a console application because we don't have a message loop. Whereas if we switch to what I've got here I've got a WinForms application, which, like all WinForms applications and like WPF applications as well and some others, has an event loop. So the way an event loop works is that every request that comes in from the user, being it a mouse move or a key press or something like that, is put into a queue, and then the queue is emptied sequentially, and each one of your event handlers in your program, so for example here we've got a go button, and then we've got an event handler that responds to that. That will do its little bit of work in response to the button press and then return to the event loop, and it just carries on being processed. And it gives us the impression of the application working asynchronously, whereas in fact it's all working in a single thread, but everything's being processed so quickly that it looks like things are happening almost at the same time. So what I've got here is simply a go button, and then we've got a list to display the results. And what I will do is take exactly the code that we had here. So we'll take that with async function and pop that in there. I will tidy that up a little bit. But what I will do, you can see it's complaining about the await. That's because the method itself has to be declared as async. And then also, rather than writing to the console, I've got this list box. So if I just say here, lbx list dot items dot add, then that's the equivalent of the console write line. And if I run that up and click go, we'll see we get the same sort of results that we had in the console application. But I just wanted to show you the difference here. So if we go back to our program and just steal the report thread, pop that in there, again change that to writing in our list box, and then let's do a report thread before and after. So that, remember, is exactly the same as we were doing in our program here. And because we've had an await between the two, that means that the two halves of the function were operating on different threads. But if we do that in the form and look at the results, then we can see we've got the same thread ID each time. So that's one of the big differences, because what we've got here is a fundamental rule to do with desktop GUI applications, both WPF and WinForms. The rule is that you're not allowed to access any of the GUI controls from any thread other than the one that they were created in, which is basically the main thread of the application. So if you've got something like your list box, we would not be able to call a method like add in any other thread but the main thread that the event loop's in. When you've got an event loop, however, when the results of the await come back, we don't immediately, in whatever thread those results have come in, carry on with the rest of the function. What actually happens is that thread puts a new request into the message queue, and then the message queue is processed on the main thread all the time. And so when that result of the await comes to the head of the message queue, then we pick up here, but we're guaranteed to pick up in the same thread we left off, And so that's why we can always see the same thread there. But that's why we're allowed to happily access the GUI controls. And that's what's always happening in JavaScript, but here in C#, it happens if we've got the type of application that makes sense for it, whereas if we've got something like our program, then it just uses multiple threads. So that means you have to be a little bit careful. If you've got data that's being shared between those two threads, then you're going to have to put some safety code in to make sure that it's not being accessed at the same time. But what we've looked at there is the similarities and differences between async and await and promises in JavaScript and async and await and tasks in C#. Two differences, essentially. One is the fact that in C#, because we've got generics and strong typing, it's a task of something, in our case, a task of stream, whereas in JavaScript, promises are just promises of whatever data type they dynamically contain. The other difference was in terms of the actual threading model. In JavaScript and in a C# application where we've got a message loop, then the code running before the await and after the await is guaranteed to be running in the same thread, whereas in C#, if we've got a console application or some different kind of application, then the code after the await is probably going to be running in a different thread. Hope that was helpful though. Any questions, pop them in the comments below, and hope to see you soon.